All right, everyone. Thanks so much for sticking around for the exciting close of today's session of the Congress. My name is Ben McCall. I'm an Associate Director for Campus Sustainability with the Institute for Sustainability, Energy, and Environment. And it's my great pleasure today to introduce Richard Heinberg, who's giving our keynote talk. Richard grew up in the Midwest, studied at the University of Iowa, apparently took a tour around North America, and has been a writer on environmental topics for about 25 years or so. For the last, I guess, maybe 10 or so years, he's been one of the leading scholars, I would say, in the world on the topic of depletion of fossil fuels and the idea that one of the consequences of living on a finite planet, in addition to having a finite amount of farmland, is that there is a finite amount of natural gas, of oil, and of coal on the planet. And at some point, we will reach a point where it becomes more and more expensive to get fossil fuels out of the ground. And he's written a series of books. I've brought a few of them here from my collection here. The End of Growth, one of my favorites, The Party's Over, Peak Everything, and a book on fracking called Snake Oil. So just to name a few. He's an exceptional author, so if any of you are intrigued by what he has to say tonight, which may come a little bit out of left field for some of you, I'd encourage you to take a look at some of these books. I guess I should close by saying that Richard is a senior fellow at the Post-Carbon Institute in California. This is a nonprofit think tank that is devoted to the study of how our world will change as we pass the point where we can no longer extract more oil and more fossil fuels every year than we did the previous year. So I don't want to eat into his time, but please join me in welcoming Richard to the podium here.
Thanks so much, Ben. Well, the presentations I heard today were excellent and very optimistic. And I wouldn't want you all to leave a conference about sustainability without having had at least a homeopathic dose of doom and gloom. So if I say some things from time to time during this talk that seem, less than giddily optimistic, just think of it as an effort in the direction of balance. I will be talking almost entirely about energy over the next 45 minutes. And I've come to see energy as really the key to understanding not only food systems, but economic systems. It's really the key to life itself. Without energy, literally nothing happens. So they didn't teach me this in school. And I really wonder why, because unless and until we get energy and understand the role of energy in our daily lives and in the way the world works, I think we're mostly flying blind. The energy that we used prior to the fossil fuel revolution came mostly in the forms of firewood and muscle power. We used firewood to heat our homes and in some industrial processes, increasingly during the 19th century for running steamships and steam locomotives and so on. And we used muscle power for getting things done, for the most part. Certainly in agriculture. Of course, not all of that muscle power was human muscle. A great deal of it was animal muscle, and a lot of agricultural land during the 19th century was devoted to growing crops to feed traction animals. And of course, if we're talking about early 20th century America, a lot of that muscle power was literally slave power. What we've done with fossil fuels is substitute fuel-fed machinery for muscle power and to a very great extent for firewood. We still use biomass. We still use firewood. But we've added all of these new energy sources to it. And instead of having literal slaves, human slaves, we now have energy slaves. The average American relies on this energy services that would be equivalent to the labor of, let's say, 150 people working day and night, 24/7. You can understand this intuitively if you think back to the last time you ran out of gas in your car and had to push your car off to the side of the road. Think of how much effort that actually was. Well, think how much effort then it would be to push your car for, let's say, 20 or 30 miles. It would be roughly the equivalent, depending on the size of the car and the size of your muscles, let's say the equivalent of 8 weeks of hard labor. Well, we get that done for us, getting our cars pushed for 30 miles, by a single gallon of gasoline for which we're paying $3 and complaining. So we're getting the energy equivalent of 6 or 8 weeks of hard human labor for $3. That's incredibly cheap energy. And that is the magic of fossil fuels that created the Industrial Revolution. That's why we substituted energy slaves for human slaves and animal slaves. And as we did so, the need for human labor on farms diminished dramatically. And this has been especially true in the industrialized countries like the United States. This is a process that's still very much underway in many other countries around the world. None of this is news to any of you, but it's interesting just to see the graphical representation. This was data from 2004. If we were to redraw the same graph today, some of these countries, especially China, would have moved down a bit and to the right. There's a very clear correlation between the amount of energy consumed per capita in a country and the percentage of the population working at growing food. So we have adopted a food system that is overwhelmingly dependent on fossil fuels, and especially oil. Oil is the key fossil fuel for agriculture, although natural gas comes in a close second because it's the feedstock for nitrogen fertilizer. And as we can see, use of nitrogen fertilizer has become somewhat more efficient in North America, but the use in the less industrialized world has increased really dramatically in recent years. So here's the overall food system and the energy expended in delivering one food calorie or kilocalorie. Add all those numbers together and it adds up to about 7. We invest about 7 units of energy, almost all of it from fossil fuels, to produce each calorie of food. And this is the U.S. food system. But it's generally true of food systems in industrialized countries. Now, this would have been impossible in the pre-fossil fuel era. Agriculture was humanity's primary way of producing useful energy via the food we ate, which enabled us then to use our muscles to do work, right? But now we have a food system that instead of being a net producer of energy is a net consumer of energy, and to a very substantial degree. So we are very reliant on fossil fuels for our current food system. And it's sort of like having discovered buried treasure. You know, these energy sources, oil, coal, and natural gas, are completely unlike the energy sources that we knew previously, in that they are more energy dense, and especially in the case of oil, more portable, perfect for processes that involve transportation. And so they have enabled us to grow our economies very rapidly. We attribute very often economic growth to technological innovation, and certainly there's a great deal of truth there. But how much of that technological innovation grew out of the effort to make use of this temporary abundance of cheap, concentrated, portable energy? Now, as good as fossil fuels are, they have a couple of drawbacks. One of which, of course, is that as we burn them, we release CO2 into the atmosphere, which is not only changing the climate, but also changing the acidity of the world's oceans. They can't keep doing that forever. We're clearly on an unsustainable path there. But also, these are, by definition, non-renewable resources. They were created millions of years ago through processes that aren't occurring in any meaningful way in the present. So our reliance on fossil fuels is unsustainable. And we've talked about sustainability today, but I think it's important to define sustainability for ourselves in kind of a hard way. Very often the word is used in sort of a fuzzy way, but think about it. What's the basic content of sustainable? It means that you can continue to do something for a very long period of time. And if we're thinking in terms of civilizations, shouldn't we be thinking in terms of centuries and millennia? Can we continue using fossil fuels for centuries and millennia to come? Clearly not. So a definition of sustainability would have to include factors like, are you increasing the rate at which you're extracting non-renewable resources of any kind, minerals, metals, as well as fossil fuels? If you are, certainly that's an unsustainable situation. Are you harvesting renewable resources like trees, fish, or topsoil at a rate that is faster than the rate of natural regeneration? If you are, that's clearly unsustainable. Are you introducing toxic substances into the environment? That's unsustainable. That's basic definition. Now, if you take that basic definition seriously, virtually nothing we are doing right now is sustainable as a society, as a civilization. So that puts the bar pretty high. And in fact, among the community of sort of sustainability thinkers, I would say the conversation really is all about the tension between the potential for economic collapse if we take sustainability seriously and try to get off of fossil fuels as quickly as we can. Well, that's really hard. Suppose we tried to reduce fossil fuel consumption by 10% per year. Well, our economy couldn't grow under those conditions, and we'd have economic collapse. But on the other hand, if we don't pursue sustainability rapidly enough, then we get to a point somewhere along the line where we face ecological collapse, which will then again drive economic collapse. Now, and the problem here, and where the discussion is how big is that overlap? How much time do we have? How much wiggle room do we have between those two potentials? And the problem, of course, is the longer we wait to move toward ultimate sustainability, the less room we have for adaptation. Okay, so back to fossil fuels. I'm going to talk a lot about oil because, again, oil is our most important fossil fuel, and certainly for our food system. This is what the oil industry looked like back in the 1930s. This is increasingly what it looks like today. The oil industry has changed profoundly, and especially just during the last decade. During the 20th century, oil consumption in the U.S. and the rest of the world increased at an averaged rate of about 1.5% per year. That rate has declined markedly during the past decade. At the same time, the price of oil globally has increased, again, quite dramatically, going from roughly $25 a barrel to roughly $100 a barrel today. And that's a much more rapid increase than other price inflation. Now, why is the price of oil going up so much? Well, it has a lot to do with the increasing costs of finding and producing oil. In the years from 1998 to 2005, the global oil industry invested $1.5 trillion, and for that investment, it got 8.5 million barrels a day in new production levels, right? From 2005 to 2013, the industry invests more than twice as much and gets less than half as much in return. This is the law of diminishing returns in action right before our very eyes. Now, the thing about high oil prices is that they have economic impacts all through society because we depend on oil for so many things. Well, transportation. Transportation is at the heart of trade, and trade is implicit in everything we do. So when the price of oil goes up, that means there's less discretionary money for other things to happen within the economy. So when the price of oil has gotten up to about $100 a barrel over the past few years, we've found that economic growth in general has become more difficult, especially for already industrialized countries. But the industry needs prices that high, and even higher, in fact, if it's going to go after the sources that are left to develop. The tight oil in places like North Dakota and South Texas, polar oil, ultra-deep water oil, and so on. So if oil prices are sort of maxed out at $100 a barrel, if they go much higher, we're likely to see recessions. Then what does the industry do if it can't get higher prices? Well, it starts canceling upstream projects. And that's what's been going on over the last couple of years. This is a graph straight out of Wall Street Journal, and it shows what's happening with the oil majors, ExxonMobil, Royal Dutch Shell, Chevron. We could add Total and some other companies, and it's basically the same story. Soaring levels of investment, but actually declining levels of production. Where we see that global oil production has been increasing, it hasn't been in the majors, in the big oil companies that are publicly traded. It's in the nationally owned companies, a few of them, and in the smaller companies that are willing to take on a lot of risk and a lot of debt. And those are the companies that are typically involved in hydrofracturing and horizontal drilling. This is a really important. Unfortunately, this didn't translate very well to the Windows PC, so you can't read the words on it very well. I should have caught that earlier. This is the pyramid of oil and gas resource quality, and a lot of what's on this graph can translate to other resources like minerals and metals, but it's really useful when thinking about fossil fuels. Most of the fossil fuels we use are in the category of conventional resources. And when we're talking about oil, we're talking about onshore oil that is drilled in a conventional way with vertical wells. But as we drill down through the resource pyramid, which is what we do metaphorically, following the low-hanging fruit principle, we've extracted the cheapest, easiest to get resources first and left the hard stuff for later. Well, as we get into the hard stuff, we get out of that capstone area of the conventional resources and more into the unconventional. Now, the good news is that there's way more fossil fuel resources in the unconventional category than in the conventional category. We're not about to run out of oil, coal, or natural gas. Far from it. There are enormous amounts of hydrocarbon molecules in the Earth's crust. What we are running out of is the conventional resources that are cheap and economic to extract. We get to that white dotted line is the price technology limit. That's where, yeah, you could get more out of the ground, but the technology is so expensive that we can't really afford to do it. And then the next double solid line is energy in equals energy out. And that's where it costs about as much energy to get the fuel out of the ground as you will get from the fuel by burning it. Okay, so at that point, oil becomes useful maybe as a feedstock for pharmaceuticals and chemicals or plastics, but it ceases being an economic fuel. Okay, so we're burning our way down or drilling our way down toward the price technology limit and the energy in energy equals energy out limit. And we're pretty far along that path. When I say energy in equals energy out, that's shorthand actually for a very important energy concept, which is energy returned on energy invested. And this was part of the magic of fossil fuels in the early days. We had to invest a trivial amount of energy in exploring for oil and drilling a test well and so on, compared to the amount of energy that we got from that well once it was successfully drilled. Now, the energy returned on energy invested of oil and natural gas production is declining as we burn through those conventional resources. And meanwhile, the alternative sources of energy that we have to replace them are generally of lower net energy quality. They have lower energy return on investment. I'm thinking now especially of solar photovoltaics. The latest study from Spain suggests an energy return on energy invested somewhere between 2.5 and 5 to 1. Now, if that were a financial investment, it would sound pretty good. If you could, invest $100 and get $250 or $500 back, great. But as a society, we need very large energy returns because almost everything we do uses energy, whether it's transportation or education or food preparation or building construction and maintenance, having a symphony orchestra in your town. It takes energy, but it doesn't produce any energy. So the little bit of energy that we invest in energy extraction or production has to be very productive in order to fund all the stuff we want to do with that energy, right? So with fossil fuels, we've gotten used to an energy return on energy invested in the range of 30 to 1 and up. But that's, as I say, that's falling. In the U.S. currently, oil has an energy return on energy invested of less than 20 to 1 and declining rapidly. And many of the renewable sources of energy, again, are considerably less. So it appears as though we are moving toward a future where we will have less energy, less useful energy. Even if the gross amount of energy being produced within society remains constant, less of that energy will be useful for discretionary purposes. More of that energy will have to be plowed back into producing the next increment of energy. This is a schematic of what the economy looked like in 1970 with energy inputs and how much of that energy ends up in consumption, how much of that consumption is discretionary versus staples, how much has to get reinvested, and so on. This is where we're headed in the world of 2030. And you notice that on the lower right, the discretionary and staples, they're smaller, even though the amount of energy input into the economy is much larger. Now, this has real implications all throughout society, and certainly for the food system. But this is not what we're hearing. In the media, generally, what we're hearing is lots of happy talk about how the U.S. is now producing more oil than it has for the last 20, 25 years. We're closing in on, if you count all the unconventional sources, we're closing in on 10 million barrels a day, which is up where Russia and Saudi Arabia are. And it's all due to the miracle of new technology, hydrofracturing, horizontal drilling. Same with natural gas. The U.S. is producing more than ever. Well, what's really going on here? Is this the game changer that we're being told, or is it sort of the last gasp of a system that's moving into a increasing dysfunctionality? Well, we at Post-Carbon Institute were very interested in what might be the answer to that question, so we decided to do our own homework. We purchased the rights to data on over 65,000 currently producing oil and natural gas wells that are specifically being produced by horizontal drilling and hydrofracturing. So we specifically went after the data on the miracle wells. And we looked at the location of each well, the initial production rate, and the evolution of production over time. And this is an ongoing analysis. We published a couple of years ago, but we have a new updated publication coming out next month, which you can find a link to. You will be able to find a link to on our website. These graphs are from the new data. Haynesville shale gas well in Louisiana. First year's production declines by about 65%. This is typical of both tight oil and shale gas wells, very high decline rates. So at the end of the first year, production has already fallen by roughly 70%. That means that the industry has to drill and drill and drill in order to keep production steady, much less increasing. Well, that's what they've been doing. They've been drilling tens of thousands of wells in a very brief period of time, and that's really what this flood of production is all about. But does it have legs? How long is it going to last? Well, there the location is important, because what we found in looking at the initial production rates and evolution of production per well was that within each of the plays, each of the geographic areas where production is happening, there's a small core area or sweet spot where initial production is fairly prolific and the decline rates are lower. Those sweet spots are pretty small, usually a county or two in size, and those are being drilled out very rapidly. Once the companies get outside the sweet spots, costs of production go up, and many of the companies are losing money on natural gas production at current prices. Almost all of the companies are up to their eyeballs in debt and relying very much on hype to maintain the value of their stocks and to attract new investors. This graph also shows what's going on, number of operating U.S. natural gas wells and average well productivity. So average well productivity has fallen dramatically in the past few years, while the number of wells has increased just as dramatically. So again, we're seeing declining marginal returns. This is the law of diminishing returns in action. And you can look at the situation and say, well, as long as we can keep drilling enough wells, everything's fine. But at what point, does geology take over? We're in a horse race between technology on one hand, which is getting better and more efficient and more sophisticated, and depletion on the other hand. Which racehorse is going to win in the end? Well, that's clear. Depletion is going to win in the end. It's just how soon? Well, we've done the numbers, and it looks to us as though both the Bakken play in North Dakota and the Eagle Ford in South Texas, which have been the primary tight oil plays in the U.S., will peak around 2016 and decline pretty rapidly after that. So, you know, that's just a couple of years from now. Now, the Energy Information Administration of the U.S. Department of Energy, the EIA, has actually a pretty optimistic forecast, both for U.S. tight oil and for shale gas. And in our new report, I have to say, take them to task a bit, because we believe that their analysis is unrealistically optimistic. And we've had our dust-ups with the EIA before. Just recently, in 2012, the EIA issued a report about the Monterey Shale in California and forecast that this would be the biggest tight oil play in the U.S., 15 billion barrels of production potential. We looked at that report, which had been outsourced to a company called Intech in Virginia, and we thought it was a shoddy piece of work. So we looked at the geology ourselves, looked at actual producing wells in the Monterey Basin, and our conclusion was that 15 billion was unjustifiable, and it was probably a small fraction of that number. Just this year, the EIA downgraded its reserves estimate of the Monterey by 96%, down to 0.6 billion barrels. We think the same thing is happening with tight oil and shale gas in general, that there has been a dramatic overestimate of long-term production potential. Time will tell. I mean, you know, obviously it's our word against the EIA, but I would recommend taking a look at our existing report, which is a couple of years old, and especially the new data that will be out next month. So, why is that important? I've talked a lot just now about tight oil and shale gas. Well, that is our trump card, right? Take that away, and world oil production has been flat to declining for the past 8 years. So do we have another rabbit to pull out of the hat? I don't see one on the horizon. And in fact, the older legacy oil fields throughout the Middle East, North America, South America, and elsewhere, and in the North Sea, are all depleting rapidly, and we're seeing decline rates increasing. So oil is looking like a really problematic fuel, not just for the long distant future, decades and decades away, our grandchildren and great-grandchildren, but even just the next decade. So what do we use instead? That's not an easy question to answer. Oil is very hard to substitute for. We've had an experiment with biofuels in this country, especially with corn ethanol, which has been very, very marginally successful. We managed to produce a noticeable amount of ethanol, but we used more than half the corn crop to do that, and the energy return on energy invested is abysmal. It's pretty close to 1-to-1. So we're taking energy and turning it into a different form so that we can put it in our gas tanks, but is the exercise really worthwhile over the long run? Batteries. Well, yeah, we are starting to see more electric cars on the market, and electric cars are a good thing up to a point. Where we're going to get all of the rare earth minerals to produce generation after generation of the 800 million passenger cars we currently have on the world's roads, we don't know. Making batteries is inherently unsustainable. We talked about the laws of sustainability earlier. But more important than that, you know, battery power is only really good in small vehicles. If we're not going to have battery-powered airliners or 18-wheel trucks pulling up to the supermarket, or even farm tractors of any size. Why? Because batteries are very poor at storing energy in comparison with a liquid fuel like oil. A 747 with a sufficiently large battery would not be even remotely capable of taking off, even without any passengers. And that's even assuming major innovations and improvements in battery technology. How about compressed natural gas? Yes, there is potential there, but that assumes continuing availability of natural gas in low enough price and sufficient quantity. And our research suggests that may not be a good assumption. So where does that leave us? Well, we're going to have to do some triage and look at how to transform our systems of food production and trade and transport so that we get the most bang for whatever buck we have left. Clearly, if you look at the energy efficiency of transport modes, rail comes out way ahead of anything else. So it's kind of sad, if you think about it that way, that we have summarily destroyed most of our rail infrastructure in this country over the course of the last 50 years. Where I live in Santa Rosa, California, we only have one set of tracks going through town, and there hasn't been a freight car on those tracks in over a decade. That's typical throughout much of the country. The Northeast has more rail infrastructure than the far West, but we are not ready for the energy future. Truck is pretty low on the energy efficiency totem pole, and that's what we've basically bet our food system on, is delivery by truck. Okay. Next. There we go. Just wanted to show in graphic form the relationship between oil prices and commodity prices, corn, wheat, soybeans. We got a real wake-up call back in 2008. Of course, we all remember 2008 as the year when the economy crashed. And we think primarily of what was going on Wall Street in that regard. But we should also remember that in 2008, the price of oil was bid up to almost $150 a barrel in July, August of that year. And almost immediately, food prices went crazy. And as a result of higher food prices, as the price of oil plummeted, but then it shifted back up again. And as the price of oil went to its new normal of roughly $100 a barrel, we've seen more political instability around the world in countries where people spend a lot of their daily income on food, as, for example, Egypt. Here's the fertilizer price index in 2008. Same thing. You know, as the price of oil went up, the price of fertilizer went up. And then when the economy crashed, why did the price of oil go down? It was because the economy crashed, which lowered demand for oil. People who didn't have jobs weren't interested in driving to work. So we crashed our demand for oil, which caused the price of oil to decline. So I'm very careful never to make forecasts about the future price of oil. You know, you would think, having seen some of the slides I've shown you, that I would be saying that the price of oil is going to go up and up and up. That's not necessarily the case. If the economy crashes again, then the price of oil could very well fall substantially. But we would be in a situation where oil was still unaffordable even at a lower price, which was exactly the situation we were in early 2009. Of course, oil is not the only non-renewable resource that we use in modern industrial agriculture. Also, phosphate rock, which is depleting rapidly around the world. And there are various estimates of how many decades we have left of phosphate rock if we continue using it at current rates. But those conflicting estimates are, you know, within the range of decades, not within the range of centuries or millennia. So one way or another, the way we do agriculture has got to change. Now, there is some good news in all of this. We have reduced our energy use on farms from the high point that it reached around 1970, 75 to today. We've decreased the energy use on farms by about 30%. So that's a good first step. We've got to go much further than that. Now, clearly, some of that energy used on farms could be produced on farms in the form of biofuels. Just because biofuels are not a good fix for the economy as a whole doesn't mean that they can't be useful on the farm. In fact, the closer they're used to the point of production, the more efficient they are. Here are some basic strategies that I think we will have to deploy in one form or another as we move toward post-hydrocarbon food systems. Replacing powered machinery with human power, we're going to need lots more farmers. We'll need more people growing food. I gave a talk a few years ago called 50 Million Farmers. That was a rough back-of-the-envelope estimate that I made of how many new farmers we're going to need over the next 20 years. Most of the farmers I know are in their 50s or 60s or 70s. We don't know who's going to be growing food in this country in the next 20 years unless we can make farming an attractive and profitable enterprise for young people. And fortunately, there are young people out there who really do want to farm. If you don't already know about it, there's an organization called Greenhorns that is made up of idealistic young farmers who are aware of some of these issues, and they passionately feel that farming is the most important occupation that they could take up at this time in human history. We need to use ecological knowledge in place of chemical firepower. Why? Because most of that chemical firepower is fossil fuel based. If it's not made out of oil or natural gas, it's transported from point of manufacture to point of use with oil. And so that also gets to localizing production and consumption. Of course, none of these are necessarily absolutes. We've been transporting food for a very long time. Prior to steamships, sailed clippers were carrying large amounts of tea from China to Britain and other points in Europe. So there was long-distance trade in food or food-related items, but they were specialty items and high-value items. For the most part, staples were produced close to the point of consumption because transportation was difficult and expensive. And it's going to get more difficult and expensive entirely foreseeably as time goes on. So we need to localize production. And we need to think in systems. Again, a food system is not just what happens on the farm. It's also all of the other, when we looked at that pie chart earlier, all those other energy using activities like packaging and processing also need to be thought of, and cooking for that matter. How much can we do with solar cookers? Quite a lot, in fact. So if we think in terms of systems, we can find ways to reduce our reliance on fossil fuels, both for reducing greenhouse gas emissions and for making our food systems more resilient and sustainable in the face of fuel insecurity. More good news. When I say local food, I'm talking about one of the, if not the most important trend in the American food system today. The USDA has called it out as the most important trend currently. This is just a picture of what's going on in my town, Santa Rosa, California. I could give you a whole hour's lecture just on what's happening with local food there. It's really exciting. And organic sales have increased, as we heard earlier today. Why is that important? Well, it's not just about the quality of the food or using less chemicals because it's more eco-groovy. It's also because, in principle, it's not always true in practice, but in principle, organic agriculture uses less in the way of fossil fuels. So as we move toward more organic production, we also need to think about that as a priority, actually designing organic systems specifically to exclude dependence on fossil fuels. Now, is it possible to change our food system fast enough to avert some of the kinds of risks that I've alluded to? Well, in principle, I think it is, and we showed that back in the 1940s with the Victory Gardens. 40% of U.S. fruits and vegetables were produced on people's backyards or back lots or vacant lots in cities, just because everyone decided that that was a priority and they wanted to be part of the solution. Well, if we had a similar recognition of collective necessity, I think we could do similar miracles today. And miracles are called for. We like to think that the solutions are going to come from, think tanks and universities and cities in general. But in many ways, the solutions may come also from the periphery. This is an organization, Via Campesina, that is of and for traditional subsistence farmers in the global South. And these are not my suggestions. These are the priorities, the political priorities of Via Campesina. Land reform is very important, because if we need more farmers, where are they going to get access to land? And this is a big priority. I mentioned earlier the organization Greenhorns of the young farmers here in the U.S. This is what they talk about all the time. How do we get access to land? It's all sewn up. It's become so valuable. It's been corporatized and so on. We need to find some way of making land available to young farmers who want to get in on a way of life that is ultimately rewarding and necessary for us all. So that's exactly 45 minutes. Hey, I did it. And I would just mention that if you're interested in seeing some of the background data on some of the slides I've shown, this presentation is a summary of a report we did a few years ago called The Food and Farming Transition, which you can find on our website, postcarbon.org or resilience.org. Those two sites are linked. And also, we've more recently published this book, Rebuilding the Food Shed, How to Create Local, Sustainable, and Secure Food Systems. That is a wealth of practical advice and, dare I say, optimism. So thank you very much for your kind attention.
Questions for Richard? Evan?
Richard, thank you for a really, really interesting and thought-provoking presentation. One thing that just caught my attention at the very end of your talk, and thinking about sustainable farms and small farms and young folks getting into the farming business, you hit it right on the head, and it's access to land. And but then you made a somewhat flip comment that it's corporatization. Of course, we live here in the Midwest, and we know these farmers, and they're our neighbors, and they're farming pretty big tracts of land, 1,000 to 2,000 acres at a clip. It's their land, it's in their families, and it's not accessible to young folks who want to get in. So how do you think we're going to resolve that? It's not just a corporatization issue, in my view.
Right, you're absolutely right. And many of the folks who own large chunks of farmland and are getting toward retirement are faced with a situation where their sons and daughters don't want to go into farming. So what's going to happen to that land? I think we really need some kind of movement among large landholders to find innovative ways of making that land available. And you know, in the worst instance, this could turn into a sort of new form of feudalism. You know, with the lord owning the land and the peasants, you know, growing and giving a portion on a yearly basis. Well, you know, this has got to be some kind of negotiation back and forth between those who have the knowledge, the skill, the passion, and those who have the land. You know, and I don't have an easy answer to that. I think it's a dialogue that's waiting to happen.
Wes?
Yeah, I'm farming right now and see lots of young people, exactly like you're talking about, who are interested in it. We're collaborating with a nonprofit called The Land Connection. Mm-hmm. And their whole job initially was to find land for farmers. And then they found land, now they're looking for farmers. Because a lot of people want to be farmers, but they don't have the background, the skill. So where do you see farmers being trained right now?
Yeah, that's a good question. A lot of the training is informal, and it's happening with young people who are sort of apprenticing themselves to working farmers, and this is especially happening in the organic area. There's a name for them, woofers, right? And there's also a movement called permaculture, which is much smaller scale food production, and that's being taught on a very broad scale. And I think, quite frankly, some of the education in that is fairly superficial. But as somebody who appreciates how hard it is, even to grow a good garden, much less farm for lots of other people, you know, I think much more needs to be done in this regard. We need more agricultural education that's geared toward the kinds of agriculture that we're going to need in the post-carbon future.
Amy? Or you have a question? Why don't you go first and then Amy? You can also just queue up at the mics if you want. Switch it on there.
Well, Richard, thank you for your presentation. It's encouraging. I just finished my dissertation on community gardens, so to see in your presentation as well as in another talk that was given earlier this week by someone from the Department of Health is encouraging. In terms of maybe what you can forecast, what might be something in the future coming down in the next year or so in terms of that would galvanize this country, not necessarily around victory gardens, but something of that nature where you have the local, even the novice, learning about doing some basic practical things in terms of agriculture and feeding the local population?
I wish I could say it was you know, something entirely painless and you know, happy, but I think that, quite frankly, that what's most likely to galvanize a change in our system is failure. Failure of the current system in some shape or form. A steep rise in food prices relative to people's ability to pay, I think, is likely to cause a lot of people to start rethinking our food system and stop taking it for granted, because that's the situation now is that most of us take it for granted, and we figure, well, it's working well enough, why mess with it? And until it's clear that it's broken, I think not enough of us are going to want to to have the courage to step up and really start doing something about it.
Hello. I'm really excited to hear you talk about local food production, and something you addressed already is farming and farming more closely to consumers. And I'm curious as to what you think urban agriculture, specifically in cities, not just in someone's backyard, not just in a farm, even in the Midwest, but specifically in cities, what part of the solution do you think that plays?
I think that's going to be an increasing part of the solution. If you look back historically at cities in the 19th century, they were centers of food production. They didn't produce all of their food. All cities historically always have been net importers of resources and people from the countryside and food. However, that trend has really reached some kind of apotheosis in the 20th century with the modern city, which just imports enormous amounts of everything and only produces manufactured widgets to export. Increasingly, homes are going to be places of production as they were in the 19th century and earlier, and less places merely of consumption. And the same is going to be true for cities. And we see that trend in places like Detroit, where the kinds of, sort of negative economic trends coalesce. We see people plowing up vacant lots and creating community gardens. This was also a strategy in Cuba, by the way, which is a really important object lesson. I don't know how many of you know the story of the Cuban special period in the 1980s. Cuba was even more reliant on fossil fuels for food production than the U.S. in terms of use of oil per unit of food production. They used big old Soviet tractors and imported cheap oil from the Soviet Union, which was the world's foremost oil producer at that time. So when the Soviet Union collapsed, suddenly Cuba lost its source of subsidized cheap oil, and the Cuban food system nearly collapsed along with the Soviet Union. So what they did was very rapidly reimagine the food system, and they did that by very quickly training up more food producers, growing more food in the cities on tops of buildings and parking lots, plowing, in some cases even tearing up streets, so that they could grow the maximum amount of food close to where it was being consumed. And, of course, they got rid of the old Soviet tractors and started breeding oxen for animal traction. And they managed to avert what could have been a real humanitarian catastrophe. The Cuban food system continues to evolve, and, of course, there are legitimate questions whether a democratic country like the United States could implement those same kinds of rapid draconian policy shifts as Cuba was able to do. But nevertheless, I think it's important to see, what they did and how rapidly they were able to do it.
Can you reconcile a lot of the modern development of molecular and cell biology, biotechnology with organic farming and small farming? Do you see it going together?
I think it's going to be modern biotechnology is not going to be, I think, very helpful in the situation that we're seeing with more problematic fuel supplies. And the reason is that biotechnology largely depends upon centralized production and then distribution of seeds, whereas more traditional forms of plant breeding that involve seed saving within communities, I think are going to be more resilient over the long run and even over the short run if we have a fuel crisis.
in Cuba during this pressure period. Wasn't as rosy as it's been written, let me tell you. And there was a dual.
There you go. I think it's on now.
Anyway, give me yours. Yeah. It wasn't as rosy as you picture, or literature from Cuba says. Those Cubans who have access to dollars did fine, and everybody else really had to scrounge. So I don't think it's something we want to bring here on the country. They were doing a lot of not organic, but urban farming in the cities while I was there in August, the height of the rainy season in a tropical country. There was nothing growing in the countryside. Mm. So I mean, zero for I traveled several hundred kilometers there. So it's a funny one. When I'm a soil scientist, I was there to get some information and so on. I couldn't get any reliable data on the things they claimed they were doing. And when is the data? It says, oh, we're working on it, still working on it. So take it with a grain of salt. Okay. But what you said, and I came a little late, but I just checked with Evan here. You pretty much discarded renewables, and you pretty much are telling us that we have to go back to the 18th century or so. Trouble is, we're 7 billion right now, and we're going to have at least 9. Your analogy with the old cities in the 1900s just doesn't play out, because the people are much larger. So declining oil supplies, irrelevant alternative supplies of energy. What are we going to do? What's your answer to all that?
Well,
bring it together.
Sorry if I implied or seemed to imply that alternative energies are entirely irrelevant. They're not. And if we were smart, we would be building as much renewable energy capacity as humanly possible right now. We're not. Renewable energy globally solar and wind is fairly trivial. As we do bring on renewable energy supplies, I think we're going to find that the way we use energy is going to have to adapt as much as the sources that we're getting it from. Because these different sources of energy have different characteristics. They are location specific, and they are intermittent. So we've built our current energy infrastructure around energy sources that are available 24/7 and that are highly energy dense in terms of land area as well as fuel dense. We're talking about sources of energy that are much more geographically extensive. Compare a wind farm producing the same amount of energy as a natural gas well, much more geographically extensive. So it's going to be a learning curve. It's not going to be a simple matter of unplug the coal power plant, plug in the solar panel, and keep on business as usual. It's going to be much more complicated than that. And I think the kind of society that we'll end up with is not going to be a 19th century or 18th century way of life, but it will have some qualities of daily life in previous times. And if we do this intelligently, I think we can have the best of what life may have been like when we experienced more of a sense of groundedness in community, more of a sense of ownership of community, less of a sense of just sort of pick up and move whenever you feel like it because it's so cheap and easy. I could go on, but I can't paint you a picture of what life is going to be like in a post-carbon world because we haven't invented it yet. But I do see some of the constraints that will shape our choices as we move to a post-carbon world, and that's what I've tried to explain.
Hi. Even though local produce is a common trend, what do we do with our global appetites? Because there are so many foods that cannot be grown locally.
Well, I think our appetites will inevitably have to change according to what's actually affordable and available. Adaptation, I think, is going to be largely driven by necessity. I think that's going to generally be true of the whole energy transition. If it could be otherwise, we would be much farther along than we are right now, because there are a lot of visionaries, people like Lester Brown and Wes Jackson, and I could go on with a list of some of my personal heroes who've seen the handwriting on the wall for the last 40 or 50 years as to where society needs to move in order for us to have an easy transition to sustainability. And for the most part, we haven't done it. So I think we've sort of boxed ourselves into a corner where most of the transition is going to be driven not by choice or opportunity, but by necessity.
Okay, let's take one last question from Alex here.
Hi. So I really loved your talk. It was awesome. I loved a lot of what you said about sort of getting back to the land.
Do I hear a butt coming?
But not necessarily a butt. More just
That's okay.
question.
Sure.
We've heard a lot over the day of how we need to become a lot more efficient with our farming techniques. How we really do need to incorporate, a lot more biotechnology, maybe higher production crops. And I was wondering how and that's just, a fact based on data with population growth, how you consolidate that idea with a more organic method of farming that is better for a post-carbon world, because that's also coming up.
Mm-hmm. Yeah, well, it's hard to reconcile all of those things, and I think we'll sort it out as we go along. Intensification, good idea, but how do we do that? Miguel Altieri at University of California, Berkeley has done research on how intensification can be accomplished within the context of traditional peasant farming societies. That's a very different vision than that of the sort of green revolution solutions. Who's right? What's going to actually work on the ground? Well, we'll find out as we go along. My guess is that Altieri may have some useful data in that regard, because what he's talking about is a way of farming that generally has been sustained for centuries already. So it's more likely, I think, to be reliably sustainable for some time to come.
Please join me in thanking Richard once again.
Illinois.